Welcome back to Computer Science 248 Operating System Programming. We looked at the VI text editor, a visual text editor, and we saw a bunch of commands that we can use to edit files. I'm going to change gears a little bit and look at the file system in Linux and Unix in general. So this is pretty much the same for Mac OS X, Linux, Unix in general, and a lot of these things will also apply to things like Windows. Along the way, we will see a bunch of commands, and there's people always ask me, well, which commands are the most important? Which ones should I memorize? I would say you don't. You might want to have a handy list of commands handy. Keep it with you so that you can refer to it. But for the most part, I don't think you really need to make a huge effort to try to memorize things. You'll just remember things as you use them. Okay, that said, let's get started. So this is chapter 5 in the book, if you have it. So the first two chapters in the book looked at, this is the first of two chapters that will look at the file structure of Unix and also look at commands that deal with the file system. Chapter 8 is the second one, chapter 5 is the first, and then chapter 8 will also look at the file system. Okay, so we'll look at basic concepts of files and directories. If you're not sure what directories mean, probably use the word folder. It's exactly the same thing. On Windows and Mac OS X, you typically tend to use the word folder. From now on, I'll use directory just to keep things consistent, just so that, because in Unix, you don't use the word folder, you use directory. It means the same thing. Doesn't matter to me, but I just want to stay consistent with the book. Okay, so we will look at the hierarchical tree structure. If you're not sure what that means, chances are you've used it in Windows or Mac OS X. And so we'll review that. So in this chapter we'll define the terminology used in the Unix file system, and words like directories and hierarchical tree structure of the file system. Those are all things you want to get used to. Okay. So for the main part, we will just discuss commands that allow you to change the file system, move around, or navigate the file system. We'll look at naming conventions for files and directories and show you basically how most Unix file systems look. Okay. So why do we even have a file system? Well, you have a hard drive typically, or you can use the file system for other things too. But you need a way to organize all your data, and that's really why we have a file system where you have directories in which you have subdirectories and files. Okay, so Unix allows you to divide your hard disk into many units called directories and subunits called subdirectories. What are subdirectories? Are they different from directories? No. They're all the same pretty much. So a directory is just a container for files and other directories. So that's how you get nesting of directories within directories. So you have one directory containing other directories inside it. So Unix provides commands to create, organize, and keep track of directories and files on the disk. There are three main categories of files. There are more, but let's just say for now that there are three of them. There are regular files. There are text files, like the ones that we used VI for. We said VI and file name like XYZ, and then it was just a regular file. So a regular file contains a sequence of bytes that could be, for example, code like a C program or a shell script, or data that you have to analyze, or a text file, things like that, PDFs. Those are all regular files. So a Word document would be a regular file, so would a text file, or a PDF or a movie file. Those would all be regular files. Directories are actually also files. So you don't think of folders being the same thing as a file, but in a sense they are. A directory file is just a file that contains information about other files. And those other files might be directories too. So that's why directories can contain subdirectories. So a directory can consist of a number of such records in a special format that's defined by your operating system file system structure. Okay, so far regular files, text files, movies, MP3 files, all of those are regular files. Then you can have directory files, which you can think of as folders. And I'll try to stick to the term directory instead, rather than folder. Every once in a while, I like both terms, so I'll try to stick to directory, but every once in a while you might hear me say folder, and if you do, just think directory. Apart from these, there are special files called device files that contain specific information corresponding to peripheral devices such as printers, keyboards, disks, mice, so on. So these are special files that allow you to interact with hardware. Okay. So directories are an essential feature of the Unix file system. You have anywhere you go, if you use a Unix system or Mac OS X or a BSD system, Linux, even Windows, you have directories. The directory system provides the structure for organizing files on a disk. People have looked for all kinds of good ways of organizing data. This is, so far, it's very much the only one that everyone has agreed on to give you a nice way of organizing files. In Unix, the directory structure is organized in levels known as hierarchical structure. All this means is that a directory can have directories inside it, and so you can get this tree structure. Once you see the picture, you've pretty much seen it. For example, if you have a C drive in Windows, this can have a whole bunch of things like program files, and then user information, things like that, the system folder, and so on. That's basically the same idea. Most Linux systems, you'll have the root, which is denoted by a /. Inside that directory, you will have other directories labeled. Typically, you will always have a bin directories, which stands for binary, lib directory, which stands for library, user, that's more like user-related files, although it's not home directories for each user. That's you. Although the book says that you will find it here, you don't see that anymore. More and more people are moving away from /usr. Your home files are not usually over here. And then you have devices, DEV. Okay, so this is the hierarchical file structure. That is, you have directories inside. So these 4 directories are considered to be inside this root directory, which is a //. Then each one of these directories can have subdirectories, and each one of these can have subdirectories, and so on. There's no limit to the number of levels. Can you have a subdirectory that's way down here in the hierarchy that contains all of this? Actually, no, but it's sort of possible. This is called hierarchical. It's one direction. That is, this contains all of these directories. This contains all of these directories. There is no directory like this one that can somehow magically contain this one. Right? So there's a hierarchy. This is at the top. This is further down. That's all hierarchy means. Okay. So in Unix, BSD, Mac OS X, those kinds of operating systems, the highest level directory is called a root, and all other directories branch directly or indirectly from that root directory. So that's the hierarchical structure of file systems. Most file systems have this structure. It just works, and it's found to be like one of the best. ways of organizing files. Okay, so we will use the terms parent and child. So for example, the root is the parent of all of these directories. So bin is considered the child of root, so is lib, it's considered the child of root. User and lib are siblings, and user might be the parent of other directories like David, Daniel, Gabriel. These could all be child directories of this parent user directory, and user itself is the child of root. Okay, so pretty straightforward. As you go down this way, you're talking about children. If you go up, you're talking about parents. On almost every Unix system you will see this kind of structure, although it's not guaranteed that you will see this. So every Unix system will have a slash directory. There is no C drive or D drive like you have in Windows. And Windows is moving towards this kind of structure too, so that when you have C drives or D drives, that actually appears elsewhere in this file system hierarchy, like the way Unix has always been. So the Windows file system is moving closer and closer to the Unix file system. Okay, so the root is the highest level, and all other directories branch from it. So one of them would be /USR, sorry. And then inside USR you might have directories like docs, man, games, bin. In Linux, users, or the people who use the system, their home directories are typically found in /home. So that's home is a subdirectory of the root directory, and so it's called /home. So I guarantee you it might be confusing now, but you'll get used to this way of talking about folders or directories: /user, /home, /user, /docs, and so on. So not every Unix system will have these particular files, but commonly you will see these kinds of structure. So if you have things that need to be printed or mailed, they'll used to go to a special place called a spool directory, and it was often in /user/spool or /var/spool. That you don't see so much anymore. People have changed the way, and so in real Unix systems, yeah, you might still see it, but these days, no, you don't see many of that. Bin, as we said, stands for binary. It holds many of the basic Unix programs. So far we haven't talked about it, but every command, pretty much, almost every command, is actually a program file, an executable file that exists in a place like /bin, or sometimes /user/bin or /user/sbin. Okay, and so we actually have used a bunch of these, like VI, for example, is probably in /user/bin. /dev contains device files. These are device drivers. Typically, you don't have to do anything with it. We will look at it. We won't really change anything, and we won't change anything in /bin or /sbin. So this sbin is different from bin only in that these are meant to be specifically used for the Unix, for the system administration. Typically, you tend to use more files from here than from here. And then a whole bunch of configuration files you'll find them in /etc. Okay, so let's take a break over here. You can take a look in your particular live CD, see what you can find, and I'll show you how to get around this in the file system next.